Assalamu alaikum, I'm Nazmul and today I'm going to present my PSM2 presentation. This is my research topic, sentiment analysis of social media posts on palm oil news using support vector machine. This is my research outline and today I'm discussion based on this outline. First is introduction, then problem background, proposed solution, research aim, objectives, research scope, literature review, research methodology, research design and implementation, result, analyze and discussion. Let's begin with introduction. Social media networks have revolutionized information sharing, the interaction impacting both society and the environment. Palm oil production, often criticized for in ecological and social harm, is a frequent topic on social media, particularly among environment organizations, as the most widely used vegetable oil, crucial of biofuel, cosmetics, and food. The palm oil industry could benefit from analyzed public sentiment on social media. The supervised machine learning method, support vector machine, has shown to be successful in sentiment analysis tasks. SVMs are famous for their capacity to manage high-dimensional data and categorize case by creating the best hyperline into several sentiment categories. We may take advantage of the SVM model capacity to recognize sentiment pattern and forecast sentiment level for unobserved data by training it on a level data set of social media news. Problem background. Around the world, oil palm is a significant crop that is widely grown in tropical area. It is a significant source of edible oil and raw material for business like food, cosmetics, and biofuel. However, the growth of palm oil plantation has also been connected to a number of environmental and social issues. On the other hand, the industry has encountered many difficulties such as unfavorable comments on social media platform. People frequently share their opinion and experience on social media sites like Twitter, Facebook, news and Instagram about a variety of subjects including the palm oil industry. An approach that can be used to examine and compare to the sentiment expressed by users on social media is sentiment analysis. The palm oil industry's stakeholder, researcher, and policymaker may find the analysis to be helpful. Proposed solution: create a sentiment analysis method that can accurately categorize text data on palm oil into positive, negative, or neutral sentiment is the suggest approach. It can be achieved through the following step: data collection. Textual information will be gathered from MPOC news that talk about palm oil and issues that are related to it. Sentiment classification: text data can be classified as having a positive, negative, or neutral sentiment by using feature extract from support vector machine. Implementing this suggested solution will allow stakeholders to learn how to general public view the palm oil industry and take steps to encourage sustainable practices. Research: this research aims to develop a sentiment analysis method that can accurately classify text data related to palm oil into positive, negative, and neutral sentiment. Objectives: 1. The study the current technique in sentiment analysis and the current issue in social media posts on palm oil news. 2. The implemented the support vector machine to perform the sentiment analysis based on the various social media post news regarding the palm oil industry. 3. To evaluate the performance of the support vector machine using the positive, negative, and highest accuracy value, then compare it with other methods. Research scope: 1. Understanding the opinion and attitudes about the palm oil among stakeholders, including producers, consumers, environmentalists, and policymakers. 2. Analysis of social media posts and messaging, how it's play a part of shaping mind across the public on palm oil. 3. Determine the challenge of producing sustainable palm oil as well as how different stakeholders perceive solution to those. Literature review. In phase 1, the research talk about the literature review, a review on online learning, and review on sentiment analysis technique. Sentiment analysis is basically typically two. One is subject and objective identification, and another one is feature aspect basis. Subject and objective sentiment analysis can assess whether the sentiment convenient by subject or object. Subject based on the person, idea and feeling, and object based on the function factual information. By analysis text data such as news articles, social media posting, or product review, this analysis can shed light on how people feel about palm oil and how they perceive it, assisting stakeholders in understanding the prevailing benefit. Feature expert based sentiment analysis can explicitly identify the analyzed sentiment connected to various aspects on feature relevant of palm oil. Aspects like the effect on the environment, health consequence, economical advantage, and ethical consideration, for instance, and can each be examined separately to determine how people feel about them. This is the framework for sentiment analysis to my study. For input, we use the MPOC news. For process, we use the step like data collection, data preprocessing, then feature extraction, and machine learning classification. For input, we find the accuracy based on positive, negative, and neutral. Research methodology. This is the framework for this research methodology. For phase 1, we discuss about the literature review. For phase 2 is the study discuss about the formulation of research problem and development of a working hypothesis and goal. For phase 3, this research discuss about the design and implementation. For phase 4, this study discuss about the result analysis and decision. Research, design and implementation. This is the full process of sentiment analysis. For first, we collect data from the MPOC website. Then is data preparation. Every machine learning effort, including sentiment analysis, starts with data preprocessing. It includes converting structural data into a form that the machine learning model can be easily understand and use it. After gathering the data, the researcher must clean it up by eliminating information like URL, special character, emoji, etc. Divided the clean text into token or individual word tokenization. Divide this text into similar, more manageable component. This is the we see the preposition, labeling data, cleaning data, classifying, and streaming and tokenization. Next is feature extraction. For feature extraction, this study use TF-IDF, which is a weighting system. The relevance of word based on how frequently they appear in post and throughout the crops as well. Each word is assigned a weight that rises with frequently in the post but fall in the proportion of too frequently in other posting. Vector represented called what embedding are used to identify the semantic connection between words to turn each word is a post into fixed length vector. Then we use the sentiment classification and find the result. This is the process how we extract data from MPOC website, and after this running algorithm we can see the result. The news is positive, negative or neutral. This figure 4.6 show the MPSC website where this study collect the news data, and the figure 4.7 show the data preparation process, result and analysis and discussion. This section provides an in-depth evaluation and benchmarking of the performance metrics by each algorithm experiment on palm oil dataset. The primary objective is to offer a deep examination regarding how efficient and effective are the algorithms being used in sentiment analysis. In the context of assessment criteria like accuracy, precision, recall, and F1 score, these analyses aim to carry out a meticulous construct among few algorithms. The object here is to try to find the algorithm that perform with the most efficiently overall. Furthermore, this section will demonstrate how well each algorithm performed on the dataset, as some of the scores slightly lower it just one specific type of sentiment analysis task. Those results would yield important insight in the relevant performance of the study's algorithm, contributing to a broader discussion on machine learning technique for sentiment analysis. Let's talk about SBM classification evolution. In figure 5, we can see the SBM classification evolution result. The support vector machine method demonstrated excellent performance in sentiment analysis of the MPSC palm oil dataset, achieving high evolution score. The SBM model attained an accuracy of 90%, indicating that 90% of this prediction were correct. With a precision of 90%, the model accurately predict positive events 90% of the time. Minimizing false positives, its recall score was 89, successfully identified 89% of actual positive case and minimizing false negative. The SBM model also achieved an F1 score of 89%, balancing precision and recall effectively. Those results highlight the SBM algorithm's strong performance in classifying sentiment accurately and reliably, making it highly competent of complex categorization tasks. Now we talk about the knife-based classification evolution. In figure 5.2, we can see the knife-based classification result. The knife-based algorithm applied to the MPSC palm oil dataset achieved an accuracy of 86%, indicating that 86% of the precision were correct. The precision score was also 86%, reflecting the high proportion of true positive prediction among all positive detection. The recall score was 84, showing that the model ability of correctly identifying 84 of the relevant instance in the dataset. The F1 score, which balance precision and recall with was 85%, demonstrating the model's overall strong performance. Despite not being the most accurate model, the knife-based algorithm proved to be well balanced and effective in predictive positive instant while minimizing false negative. Comparison of the two model classification. This summarizes the outcome of how different algorithms were able to categorize sentiment in table 5.1. The difference allow for a straightforward comparison between the geographical area, showing which major performance indicate the best serviced by the algorithm at every little examination point in the table. In table 5.1, we can see the model SBM accuracy is 90% and knife bias is 86%, precision 90% for SBM, 86% for knife bias, recall 89% for SBM, 84% for knife bias, and F1 score 89% for SBM and 85% for knife bias. This paper compared the performance of support vector machine and knife bias using accuracy, precision, recall, and F1 score. The results show that SBM outperformed knife bias and both model achieving over 85% accuracy. The SBM superior performance highlighted its ability and effectively classified news based on context. To maintain high accuracy, the model must be regularly updated with a few training data and enriched with diverse text sources such as separated news site, Facebook, and Instagram. Overall, SBM is demonstrated to be a more reliable classifier for this dataset. In conclusion, this study utilized a machine learning method investigating issue content on palm oil organization. This study aimed to identify where the problems are, suggest a strategic direction for future research through both the use of knife-based classification and SPM. According to the result, an inferior count operator was less effective than superior due 90% as compared with only 86% for knife-based decision-based algorithm. This goes to show how good SVM is in tasks which are related to sentiment classification. Training data is regularly updated and re-evaluated, seek to improve the accuracy of model over time. Knowing the study technique become essential in order to rightly classify model having unique term. This helps provide the palm oil industry with additional context while also improving data retrieval requires. The comparison show that SBM-based knife bias in sentiment analysis by a huge margin is high precision, recall, accuracy rate, and F1 score confirm the importance of SBM model feature is very important in the particular applications which require predicted value due to positive result being compared identify in the predicted as well to real dataset. After all, the model access to new data will make it resilient and very fixable in the environment data continuously change.